I'm Dr. Memari, and I'm going to perform experiment 7, which is the calorimetry and Hess's law for you. So you have the data in order to complete your data sheet, do your calculation, and turn in the assignment. What is the Hess's law used for? Hess's law is used to find the delta H, or enthalpy of reaction, using series of enthalpy of different reactions, and I'm going to show you using the document for the lab. And we want to make sure to read the introduction part of the lab manual, which is going to help you to understand the theory of the enthalpy of the reaction. Then for the for enthalpy of the reaction, you can look at the for basically it's the delta H formation of the products minus the reactant, so you can get the calculation. That's one way. The most of the delta H values are calculated; they are given to you, so they are recorded in the reference books. So we do have some of these already in the reference books, like for the H2 plus O2 formation of the water, we have that delta H value as a 241.0 or 0.8. That's what we have. So if you reverse the reaction, the sign for delta H is going to change. If you multiply whole reaction by 2, the value for delta H is going to be multiplied by 2. If you divide, it's going to also be divided. If you add 2 reactions together, these 2 reactions together, the delta H values are going to be added also. How do you add the reactions together? You draw that arrow line, and then anything that's on the reactant side, you add together. Anything on the product side, you add together. Then you add the values for these 2. If the values, then you can find the delta H for the overall reaction if you add the 2 reactions together. And then you have other examples here. Let's say you have the copper sulfide that yields copper plus sulfur, and then sulfur from oxygen, it gives you SO2. If you treat this or rearrange your reaction in a way that when you add it up, it comes up to desired reaction, which is a copper sulfide plus oxygen, that gives copper plus the sulfur dioxide. If you want to find this, sometimes you have to rearrange your reaction. You can reverse it. You can multiply by 2. You can divide by half, by 2 to get half of the reaction. So you can cancel the items, the like terms from both sides of the equation in a way that you end up with desired reaction. The reactions that we are interested in today, it's the combustion of magnesium. Combustion of magnesium is not going to be easy for you to calculate the reaction by changing temperature of the water or using in the calorimeter, because it's and even if it's done, we want experimental using Hess's law. We want to calculate the combustion of the magnesium, delta H for combustion of magnesium. So using this delta H2, so we want to find the delta H1, but we have the delta H2. This is a literature value given to us. We are going to use the calorimeter in the lab and calculate the delta H for magnesium, reaction of magnesium with HCl. And then we find the, we are going to also make the magnesium oxide react with HCl and find the delta H value for that. Using these 3 reactions, we are going to rearrange it in a way that we end up with Mg plus 2 that gives MgO. Anything happens for the reaction, same thing will happen for the delta H values. Then we can find the value for delta H, delta H1. Going to calibrate the calorimeter to find the heat capacity first. That's the part A of the experiment. Sometimes I skip that part in my class, but now because not everybody is going to skip it. I'm going to do the experiment, so it's going to be longer experiment. I will just follow the procedure, and I will give you the data for part A. And since I'm giving data, even for my students from teaching the class, they are supposed to do the calculation and turn in that part A of the data sheet as well. And then we are going to do the measurement for magnesium reacting with HCl, magnesium oxide reacting with HCl, and then you can do the calculation. I will provide enough data for you to be able to do the calculation to find the enthalpy react for combustion of magnesium. So I am going to use my lab manual for the procedure. Step 1, which is the calibration of the calorimeter. The calorimeter that we are using is a homemade one. It's like in-house. We have the beaker just to support because this is lightweight. I don't want to put solution in there and it drops and breaks or pour spills. So I use the beaker just to support it. I have 2 styrofoam cups. Styrofoam cup is good because that's why you get your hot beverages in the styrofoam cup, not the glass cup without any handle. So it works for the purpose of this. So it kind of insulates the heat inside, and the heat that is generated is going to increase the temperature of the water, and you calculate the amount of the heat. There's one formula to calculate the heat. Heat equals mass times specific heat times change in temperature. So the greater the mass, the greater the amount of the heat needed to increase the temperature. The higher the temperature change is going to be, that means more energy was used. So it's kind of common sense, those 2 factors. And the last one is the specific heat. That's the nature of the compound. Some compounds, they have different specific heat than others. Water has high specific heat. It takes longer heat to heat up the water. It takes longer for water to lose heat. So it's going to be used in this experiment also. Okay, following the procedure, we are going to get beaker and the test tube. We are going to measure the mass of the test tube. So let me see what you need on the data sheet so I can record those values for you. For the data sheet, you need mass of the copper. So if you only need the mass of copper, you don't need the mass of individual. You don't need the empty container. So I'm just going to place this in on the balance and add copper, like 1/3, because it's too heavy. This copper is too heavy, and I don't want to put too much of the copper in. Then it would be harder to handle. So I put about 1/3 of copper in. I have those. Okay. Mass of the copper, 101.824. So I'm going to write here for you. Mass of copper equals 101.820 grams. Then we need the mass of the empty dry calorimeter. is 170.49. 170.90. Then we are going to place 100 ml of water. Mass of calorimeter plus water equals 269.078. Going to place the copper inside the boiling water and keep there for 5 minutes. So it's asking for mass of waters, which you get it by difference. And then the rest is coming. So we are going to wait for about 5 minutes for the copper to reach the temperature of the hot water, and going to measure the temperature of the water. Initial temperature. And cold water. 21.9 degrees Celsius. I have to give time for the copper to get hot, at least like 5 minutes. While we are waiting, there's one thing I could do to, because I can't take that of nav, otherwise the calculation is not going to be accurate. So I'm going to get the 0.25 grams of magnesium. Okay, 0.25 grams of magnesium because I need it for later. For the second part of the experiment, just getting ready for it. Point 256 grams, and I need 1 gram of magnesium oxide. That's for part B. It's good to get ready for the next step. Things. Okay. Measure the water temperature for water. Hot water. Temperature of copper, which is assumed to be same as boiling water. Final temperature for metal, water. Of this typing, so I can mixture. Yes, just want to have it ready. Okay. So we're going to add the water, add the metal to cold water, and wait for the change in temperature. So I'm just going to carefully bring it to this side because it's very hard to bring the heavy copper using the holder is not very safe. So I'm going to have to take it, slide it, and add. I have to wait for the highest temperature to reach for water. And when the temperature starts dropping, I record the number. So right now it's 28.9. If it stays in that temperature or is going to change. Okay. 29.0 is stable. 29.0 that number and the information provided in the lab notebook, you should be able to calculate the heat capacity. Okay. Now, going to move to the next part, part B of the experiment. Mass of the styrofoam cup and the beaker, dry calorimeter. Okay. We are moving to part B. Part B. We need the mass of empty dry calorimeter. One 170.458. 170.458 grams. It's different from the other one because the cup has changed. Mass of calorimeter with HCl. So I'm going to use 50 milliliter of HCl, add to the calorimeter. So 50 milliliter of HCl. Calorimeter plus HCl. You have to say the 50 or you would get it with the HCl. Mass of the solid used. This is equal to 219.809, 219.809 grams. Mass of Mg used. This is for the solid. Mg used equals 0.256 grams. Mass of Mg solid. Let me finish this part of the experiment, then I do the other part of the experiment. So everything that we have here is for Mg, for part B for Mg. Temperature of the HCl before adding magnesium. Take temperature before adding magnesium. (22.2). Okay. So we are going to add the magnesium. Wait for change in temperature. The temperature is going to increase, and at one point is going to reach a plateau. So I'm looking for the highest temperature that is going to reach. So the temperature is increasing. Because the reaction of magnesium with HCl is exothermic reaction. Going to see how high the temperature is going to go, and before it goes down, I record the temperature. So we are looking for plateau. 42.8. See, if it doesn't go higher, 42.8, actually 43. Okay, 43. .0. I was losing it. Okay, so we are done with the experiment of magnesium with HCl. Now I have to go to the other side of the data sheet where you have the magnesium oxide with HCl. Everything we are going to repeat for magnesium oxide and HCl. So right now I'm going to use the magnesium oxide reaction of MgO with HCl. Data for reaction of MgO with HCl. Okay. What do we need to find first is the mass of empty calorimeter. So find the mass for empty calorimeter first. Cool. Going to take out, keep it on the side. Another star. $173.87. 170.387 gram. Then we need the mass of the calorimeter plus HCl. I get the 50 ml of HCl. We add 50 milligram HCl and measure it again. To 21.33. We need the mass of solid used. GO. Equal is 1.00 gram. And we need the temperature of the HCl. Initial temperature for HCl. .9 degrees C. Then we need the plateau temperature. Plateau temperature is temperature after we add the solid. We add the solid, temperature is going to change. Temperature is increasing, and when it gets stable, we record the temperature. Still is increasing. Has to be stable before I record the temperature. So 38.4, still going up, so I'm just going to wait for a minute. Okay. .4. Okay. I think that's all the data you need. You have the specific heat capacity for the reaction mixture, which is assumed to be like water. You have that in the lab manual, you can use it. And everything else is calculation. It was a long reaction, especially the titration part. I had to do them all together today. So, but we have to wait until the temperature stabilizes. We can't rush through the experiment to get the best data. But you have your data, you can complete your data sheet and turn it in as an assignment. Thank you. I'm going to stop the recording, and that concludes our experiment 7.